Okay, this is question 7.35. Looks like it's a ballistic pendulum. I'm not going to try and replicate the drawing too much, but basically you have a bullet that embeds in a mass, and the mass goes up like this, and you end up with something like that. They give you the mass of the bullet's 28 grams, and the speed's 210. So if we start with P before equals P after, which is what we always do, all of the momentum is coming from the bullet. So it's 0.028 times 210 is your momentum before. Equals the momentum after, which is the mass of the two combined. So it's 4.028 kilograms times V combined after. You solve for V combined, and you get, my calculator real quick, 0.028 times 210 divided by 4.028, a really small number, 1.46 meters per second. It's because the mass of the block is so much more massive than the mass of the bullet. So once you have that, now you can figure out, like the first question is, what's the vertical component of the pendulum's maximum displacement? So you want to know what this delta y is here. So that's just equal to h in terms of, if you have kinetic energy down here transferring to potential energy up here, you can say 1/2 m. Whoops, this m is the combined mass, so that's m plus m. V combined squared equals the combined masses GH. So I'm just going to cancel those, and you get H is equal to, I'll do the math instead of writing all this out. I came out with 0.109 meters for my numbers. Then to find the horizontal component of the pendulum's maximum displacement, it's just a trig problem or a geometry. I don't even know what to call it. Geometry. 2.7 meters is the length. This was where the mass was, and then it moved up to here. So this is your delta y, or that 0.109 meters, which means this side here is 2.591 meters. So a squared b squared equals c squared. B squared is your x component. When you solve that, you get that the x component is roughly 0.758 meters. So again, start out with momentum conservation, sticky collision, so your masses combine and you get V combined. Take that and then use energy conservation, not energy conservation in terms of the collision. This is after the collision. So after the bullet's embedded in here, that kinetic energy turns into potential. So that's not a momentum, it's not an elastic collision, I should say. So do that and you get the height, and then use your triangle math to figure out what the delta x is equal to that. Good luck.